So this video lesson is all about writing proportions. We haven't quite gotten to solving them yet. This one is going to be entirely about writing them, just setting them up and understanding what they are. So first, of course, we have to understand exactly what a proportion is. And so we're going to do that by looking at an example here. In this example, we have a 150-pound person who runs moderately for 30 minutes. During this 30 minutes, that person burns about 351 calories. So what we want to understand is how many calories does that person burn if she runs for 60 minutes. Go ahead, pause the video now, see what you can do with this one, and unpause when you're ready to go. So for this particular example, it's not that entirely difficult to see. If a person burns 351 calories for 30 minutes, then we only need to multiply that 30 by 2, and we get 60 minutes. So by corollary for this particular example, we can take the number of calories that she burns, which is 351, multiply that idea by 2 also, and end up with 702 calories. And that's the answer that we're looking for here. But that is only because we have something as simple as running for 60 minutes, which is twice 30. What if we have something as complicated as running for 40 minutes? Go ahead and pause the video now and see if you can come up with a way of solving this idea, which is running for 40 minutes now, which is not quite as easy, and finding out how many calories they burn running for 40 minutes. Well, the first thing we need to notice here is that we can't use the same kind of strategy that we did for 30 and 60 minutes, because 40 is not twice what 30 is. And in fact, we could multiply it by something. We multiply it by 4/3, but that's a bit complicated. One way you might have done it is to split the 351 calories, which are used for 30 minutes. And if we split the 30 minutes into 3 equal groups, we have 10 minutes. So if we split the 351 calories into 3 equal groups, then we end up with 117 calories in every 10 minutes. Then, knowing that we're waiting for 40 minutes, 10 times 4 is 40. And 117 times 4 then should give us something that is the amount of calories for 40 minutes. That's 28. 468 calories in 40 minutes. But that's one way of doing it, thinking about it intuitively, splitting that 30 minutes into groups of 10 minutes, and then using those groups of 10 minutes to create 40 minutes. But really, let's look at it and see if we can get to it a bit more directly, because going back through this way is a little bit, you have to go off, find the 10 minutes first, and then end up at 40 minutes. Let's see if we can get to it more directly. So we're going to actually create this table, this 2x2 table, to sort of organize our information for us. At least this is the way that I'm going to do it. And so I want to organize the information in a way that I can see what's going on and how it relates to each other. So the first thing I'm going to do is I'm going to say that on one end here, we're going to have our top row be our calories burned, and we are going to have our bottom row be the time that we spent running. And so now we can look here and we can see that everything that we're going to put into this top row, these two boxes, are going to relate to calories. The bottom two boxes are both going to relate to time. And we can't just put our information in here now completely randomly. We need to organize where everything's going to go. So our columns now are going to be what we know and what we want to know. We want to know the amount of calories burned in 40 minutes. What we know, on the other hand, is that in 30 minutes, she burns 351 calories. 30 minutes, 351 calories. So again, this is just organizing my information here. One column is what we know. She burns 351 calories in 30 minutes. Now, we're going to take what we want to know. We want to know how many calories she burns in 40 minutes. But I'm not going to leave it blank. I'm going to use a variable x. because if I have a variable x and I can find a way to put it into an equation that makes sense for this scenario, I can solve it. And the way that we do that is by writing each of these as a rate. Now remember, a rate is just something that compares two different types of information. In this case, we are comparing the amount of calories that are burned to the time it takes to burn them. So I'm going to write them as a rate normally, which is, as I normally write a rate, which is the time as the second number. So my first comparison is 351 calories in 30 minutes. My second comparison is this unknown x number of calories in 40 minutes. Now if we assume that she burns about the same amount every minute as she's running, if she continues running, then these actually represent comparisons of the same thing. If we change these back to unit rates, their calories per minute should be the same. So their ratios should be the same. And when we create something like this, where we're comparing two different ratios or two different rates, we end up with what's called a proportion. Setting two ratios or rates equal to each other gives you what's called a proportion. And we can create simple proportions for things like if we compare 3 to 5, that's the same as comparing, say, 9 to 15. Or if we compare something like 1 to 1, that's the same as comparing 3 to 3. That is the same as comparing 5 to 5, etc. But when we set them equal to each other, we end up with what's called a proportion. So to set this particular problem up, we find the ratio of calories burned to minutes run that we know. We make that exact same ratio. Now it's important that both of the numerator values here in this fraction, we almost always write a proportion using the fraction notation. Both of the numerator values represent calories, and that's very important. Both the numerators have to represent the same thing. And both of the denominator values down here represent the number of minutes that you spent running. And that's important because both denominator values have to represent the exact same thing. Calories and minutes. And if you notice, it's basically the same thing as taking our table, drawing some fraction bars, and setting an equal sign in the middle. 350 over 30 is equal to x over 40. So if we set this up in a way where all of our information is very similar and worked and is put in the same ideas in the numerators and denominators by using this table, we can just take the information and make a proportion. So let's see if we can try it with another idea here. And so this is the picture of the CN Tower, which is the tallest freestanding tower in the Americas, North and South America, and until the building of the Burj Khalifa was the tallest freestanding tower in the world. So the elevator in the CN Tower travels 1,122 feet into the air from the ground up to the observation decks in 58 seconds. Now we're not going to solve this proportion, but I want to know how far the elevator travels in 15 seconds. So go ahead and think, how can I set up two ratios? One that I know that in 58 seconds it travels 1,122 feet, to find out what I want to know. How far, circle this in green because how far is similar to the 1,122 feet, does it travel in 15 seconds? Go ahead and pause the video, see if you can set up that proportion. Well, for this proportion, what we know is 1,122 feet are traveled in 58 seconds. What we want to know is how many feet, some x number of feet, do we travel in 15 seconds. So when we set this up in our 2x2 table if you want, or just immediately in our proportion if you want, what we know for distance over time is that a distance of 1,122 feet is traveled in 58 seconds. That means what we want to know is the number of feet, again, feet, making sure that both numerator values or top values represent the same kind of unit in 15 seconds. And we can see that the denominator values down here also are represented by the same kind of unit, 15 seconds. So now we just simply take this proportion as it is from the box and write it down here as a ratio. 1,122 feet in 58 seconds. Now you can skip the step of the table if you want. If you can see that what we know is already 1,122 feet in 58 seconds, then all you have to do is make sure that your feet end up on the top and that your seconds end up in the denominator. Now again, we're not going to solve it. We're just writing the proportions. Solving is what we're getting to next. So now finally, for our 4 practice problems, go ahead and try to solve these problems here. 4 problems, I'll label them for you. This is 1, 2, 3, and 4. Again, just set up the proportion. Don't try to solve it, just set it up. So if we're looking down to number 1, rather looking up to number 1, the elevator of the Empire State Building, similar to our CN Tower example, travels 80 floors in 45 seconds. So that ratio right there of what we know is simply 80 floors in 45 seconds. Now we're going to use this information to set up a separate ratio. We know that we want to find out how many floors does it travel in 30 seconds. So what we have is 30 seconds. Keeping in mind that the seconds are down here in the denominator, we're going to use the exact same unit on this side. This is what we know, 30 seconds. And what we want to know is how many floors it travels in 30 seconds. If we move over to number 2, a car is traveling at 65 miles per hour, and we want to know how many hours it would take to travel 750 miles. Now here, we don't have anything immediately useful as a rate or a ratio until we remember that 65 miles per hour is just a unit rate. That is the same rate as 65 miles in 1 hour. So if we're going to set that up as a ratio for our other set of miles, what we know is 750 miles, or what we want to know is what happens after a distance of 750 miles. Our miles are in the numerator, so that means in order to set up a correct proportion, we have to keep our miles in the numerator, set up 750 miles in a certain number of hours. In this case, our x ends up in the denominator. Not a problem, just different from the way that we've done it before. A certain recipe for number 3 needs 8 tomatoes to make 5 quarts of marinara sauce. So we want to know how many tomatoes you would need for 12 quarts of sauce. Again, what we know is it takes 8 tomatoes for 5 quarts of sauce. We know that we're looking for how many tomatoes it takes to make 12 quarts of sauce. So we're going to set up this ratio with quarts in the denominator, as it has before. 12 quarts means X tomatoes. Again, making sure that our units are in the exact same locations in either ratio, and now we have our proportion. Finally, a pack of 12 pens costs $8.99. At that rate, how much would it cost to buy 100 pens? Well, what we know is we have 12 pens for $8.99. And we're looking for 100 pens, so we keep our units in the same location. Pens is in the numerator. 100 pens in X dollars. So one more time, a proportion is just what you get when you set 2 ratios or rates equal to each other. And when we solve or set up, rather when we set up and write a proportion, we can set it up using this 2x2 table that gives us a handy way of organizing our thoughts, as long as we can label it correctly and know what we're doing, or we're always going to be given one ratio that we already know, and it's going to be used to find another ratio or rate. So you just set up one rate and make sure that your units are in the exact same locations in the fraction as your first rate for the one that you're trying to find out.